Mole ratio. So in mole ratio, we are determining the relationship between each compound in the chemical reaction. So for example, we see that there is 2 mole of H2 to every 1 mole of O2 to every 2 mole of water. Let's practice. In the first example, we have 1 mole of AlBr3 to 3 moles of K to 3 moles of KBr to 1 mole of Al. In the second example, we have 1 mole of P4 to 6 mole of Br2 to 4 moles of PBr3. And in the third example, we have 2 moles of Mn to 6 moles of Hi to 3 moles of H2 and 2 moles of MnI3. Now, sometimes we want to calculate the number of mole. First, we got to determine the number of mole that is given. Then we need to identify the unknown. Then we get the ratio from the chemical equation, the original ratio from the chemical equation, and then we solve for the unknown. So let's take a look at this example. In this example, we are trying to determine the number of moles of HBr if we are given 8 moles of MgOH2. So we're going to use dimensional analysis in order to make this determination. So in the first blank, we're always going to put what is given. So we are given 8 moles of MgOH2. So we're going to move 8 moles of MgOH2 over here. In the next 2 blanks, we're going to put down the relationship between what is given and what is that we are searching for. So we are given moles of MgOH2 and we are looking for the HBr. So we're going to put 1 mole, this right here, of MgOH2, and we're going to put it in the blank that's across from the 8 moles of MgOH2. We do this because we want to be able to cancel out the MgOH2. Okay, so what we're going to do is we're going to cancel out the MgOH2. Next, we know that we have 1 mole of MgOH2 for every 2 mole of HBr. So we're going to put in there 2 moles of HBr and we're going to put that on top. Now, all we had left in terms of units is the HBr. So now we can do our multiplication division. Note that anything on the above the lines are multiplied and anything below the lines are divided. So in this case, 8 times 2 is going to be 16 moles HBr over 1 mole of 1 mole left over here, okay? So therefore, the answer is 16 moles of HBr. And this is our answer. So let's take a look at this example. In this example, we are given 12 moles of NaOH, and we want to determine how many moles of SiOH4 is needed. So first, using dimensional analysis, we're going to put down what is given in the first block. So we are given 12 moles of NaOH. And we need to put in the second 2 blocks the relationship between the NaOH and the SiOH4. So we know that we have 4 moles of NaOH to every 1 mole of SiOH4. So we're going to put 4 moles of NaOH opposite of this one. And then we're going to put 1 mole of SiOH4 on top. We do this so that we can eliminate the NaOH. So in other words, we can now eliminate the NaOH moles, and all we have left is the mole of SiOH4. Remember that anything above the line, we multiply, and anything below the line, we divide. So 12 times 1 is 12. 12 moles of SiOH4 divided by 4, which would then give you 3 moles of SiOH4.